Sketch the graph of y equals negative x cubed plus x squared plus 12x on the set of axes provided. Clearly label any axial intercepts with their coordinates. So the first thing we need to do with this graph is try and factorize it so that we know what x-intercepts might occur. So x is a common factor of all three terms in this rule, and we can also factor out the negative. So our rule becomes y equals negative x, and if we've factored out negative x, we're left with positive x squared minus x minus 12. And you can check that if you expanded that, you'd get back to the original equation. Next, we can try and factorize the quadratic that's appeared. So our rule can become y equals negative x times, and now the factors of negative 12 that add up to negative 1 are negative 4 and positive 3. So we can have x minus 4 times x plus 3. And again, you can check that that expansion equals the original equation. So now that it's in factorized form, we can quickly find the x-intercepts of this graph by letting y equal 0 in that factorized equation. So we can have 0 is equal to negative x times x minus 4 times x plus 3. And because it's factorized, we can use the Null Factor Law to say that x equals 0, or x minus 4 could equal 0, or x plus 3 could equal 0. For this equation, we can add 4 to both sides to get x by itself, and that will give x equals 4 as a solution. For this, we can subtract 3 from both sides of the equation, and that will give us x equals negative 3 as a solution. Therefore, the x-intercepts are at 0, 0, 4, 0, and negative 3, 0. Inspecting these three solutions, we can see that that is also the y-intercept of this graph. So because of this negative sign here, we know that the cubic polynomial is a negative shape, which means it should have this shape. So taking into account the x-intercepts that we found, our graph should look something like this. So this value here was negative 3, 0. Then we had 0, 0, and we also had 4, 0. On this slide, we've had a computer generate this cubic graph, and you can see that the x-intercepts remain the same as what we found previously, and we've also included a decimal approximation of the minimum and maximum turning points for this graph.